Hello everyone.
Good morning, ma'am.
Good morning,
Good
ma'am.
morning, ma'am.
So how are you all? We're meeting after a very long time, right?
Yes.
Just a minute. So how are your preparations going? Did you all study whatever we've covered up till the last class?
Yes, ma'am.
क्या किया था हमने last class में?
Theories of emulsion.
Theories of emulsion. Right. Theories of emulsion was one part, of course, this portion, but we also started emulsion ka formulation part, right?
Yes, ma'am.
Yes. So did you all go through it? What books are you all referring?
Martin.
And for formulations? For formulations? ये चालू नहीं किया अभी तक. Okay, let me just start sharing this slides first. Okay. And you'll see the screen?
Yes.
Okay. So we've covered up these things, right, in the last class? The basic introduction, applications, types, right?
Yes, ma'am.
Yes, ma'am.
Then the multiple emulsions, right? Macro and nano emulsion. So which one is more stable, macro or nano?
Nano.
So now let us continue from here. So any doubts up till now? हमने अभी तक जो भी टॉपिक्स कवर अप किए हैं उसमें भी any doubts?
No, ma'am.
No, ma'am.
Everyone.
No, ma'am.
So today what we'll do is we'll try to complete this topic and solve a few MCQs pertaining this. Fine. Okay, you can see the slides, right? So fine, in this section now we'll understand about the formulation aspects, about the excipients, and the manufacturing aspects. And I don't think it's tough because we've gone through it multiple times here. All right. So in emulsion, since an emulsion is a biphasic mixture of oil and aqueous phase. All right. So उसका दो मेन कंपोनेंट तो एक तो aqueous phase हो जाएगा, दूसरा will be oil phase. So there's a fifth one also. इधर oil लिखा है, but then there'll also be aqueous phase. Now tell me what an aqueous phase will be. Aqueous phase में क्या होगा?
Water.
Water.
Water. Okay.
Oil globules in water.
No, I'm just talking about the aqueous phase. Aqueous phase में water can be a thing. Can I say aqueous phase में buffered aqueous solutions भी आ सकता है? हाँ? Can this also be
Yes.
qualified as an aqueous phase, the water phase in emulsion?
Yes.
Yes, it can be. Certain systems जहाँ पे तुम्हारे drug का solubility is say pH dependent. Okay, if your drug, obviously here the important component is drug also. That goes unsaid. Okay, that goes unsaid. But ये हम excipients की बात कर रहे हैं. Fine, excipients is something which is other than your drug. So if your drug is say having a pH dependent solubility, what is pH dependent solubility का मतलब?
At specific pH, it dissolves.
Yeah, only at a particular pH it is soluble. All right. Say either in water also or in aqueous phase also. So in that case, you cannot use plain water. Okay, suppose if you want to make a water in oil emulsion, तुम्हारा ड्रग का solubility water में only at a certain pH है. So in that case, can you use plain water? No. In that case, you cannot use plain water. In that case, you will have to maintain the pH of water in some range. So for that, you will be using a buffered system. So aqueous emulsion का जो aqueous component होता है, that can either be plain water, it can also be a buffered aqueous system. All right. So these are the two things which can come under aqueous system. Then in oil phase, you will have different types of oils, right? You have your, which are the different types of oils which you all know, which are used in emulsion?
Fixed oils.
Fixed oils, for example,
Palm oil.
Arachis oil.
arachis, not palm oil is not used. Arachis oil, cottonseed oil, correct? Then arachis, cottonseed, sesame oil. All right. These are some example of oils which are used for as an oil phase. You also have these days, you have MCTs. MCTs matlab medium chain triglycerides. Even they are used. You have these oleates being used. Okay. These are the different. Then you have GMOs being used. Glyceromonoleate and all. Okay. GMOs being used, MCTs being used. These days, even these organic systems are being used as the oil phase. Then another important system becomes your emulsifier, right? We studied three different types of emulsifiers. Which are the three different types? Three different types. Pada?
Surface active
Activating
agent,
Okay,
hydrophilic
surfactants.
colloids.
colloids, finely divided solid particles.
Very good. Surfactants, hydrophilic colloids, and
Finely divided solid particles.
very good, finely divided solid particles. So these are the three major types of emulsifiers used. उसमें से भी surfactants and colloids are most widely used. Okay, so emulsifier becomes important. And which is the law which we studied, law or rule which helps us understand the emulsifier and the emulsion which it will be forming? There was some rule, right? भूल गए सब लोग, लास्ट क्लास ही पढ़ा था ये. There was some rule जिसमें लिखा था कि जो HLB वैल्यू होगा उस हिसाब से वो कंटिन्यूस फेज फॉर्म करने में हेल्प करेगा इन emulsions.
Surface tension theory.
Rule of nobody.
Partition coefficient.
No. Rule of Bancroft. Did you forget rule of Bancroft? हमने कितना डिटेल में बात किया था इसके बारे में. अभी याद आया रूल ऑफ बैनक्रॉफ्ट?
Yes, ma'am.
क्या बोलता है रूल ऑफ बैनक्रॉफ्ट? You all have not prepared.
Emulsifier soluble in oil forms water in oil emulsion and vice versa.
Very good. Thank you. You all have not prepared. Huh? You all have just come for today's class. Anyways, so then the fourth one are antioxidant, because you are having water, you are having oil. Oil has a lot. It is highly prone to get rancid. Okay. It's highly prone to get rancid or oxidized and all. So you need antioxidant. So antioxidant can be your nitrogen से तुम purging कर दोगे. वरना you will use metal chelating agents also you will use. Okay, in this case chelating agents भी तुम use कर सकते हो, जैसे EDTA and all हो गया. And other antioxidants like BHA, BHT, MTG and all of that. And then obviously preservatives. If it's a preservative, हम multi dose में use करेंगे. If there's something for multi dose, then we will use preservative. Even in parenteral, in injections, when you have to give one injection only, एक ampule में से पूरा content निकाल के inject कर दिया, in that case you don't need preservative. But एक ही vial में से अगर बार 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 से लेना पड़ता है, then that is when you need preservatives. All right. So it's very important how you select the oil phase. Fine. So for selection of oil phase, it must have physical properties. It should impart desirable physical properties to your emulsion. Mane, if you're using some oil, you have options of oil 1 and oil 2. Oil 1 is forming a nice clear, even though it will appear goldenish, but it will form a nice clear type of solution. Or even the emulsion will appear nice, but here it won't be like that. इधर तुम्हें emulsion में particle size कम आ रहा है, इधर तुम्हारा particle size ज्यादा आ रहा है. You will prefer something जहाँ पे particle size कम हो. So ये सब physical properties you will see, and उस हिसाब से भी you should be selecting your oil phase. Another is the miscibility of oil and the aqueous phase. Fine. So when you're making an emulsion, okay, they will obviously both of them will be immiscible. Because both of them will be immiscible, there will be a lot of interfacial tension. Agree?
Yes.
Okay, because of this there'll be a lot of interfacial tension. So in this case you will have to use higher amounts of emulsifiers to reduce that interfacial tension. Correct? Now if you have something which has they're not that, the extent of immiscibility is not that high. Okay, so in that case you will prefer something like that, those oils which are having some more miscibility. Okay, instead of having zero miscibility, it will have say 0.1 or 0.2 times of miscibility. Okay, so all those things you will check. तुम्हें basically there's not a rule written on the rock कि ऐसे होना चाहिए वैसे होना चाहिए. It all depends on what you desire. As a formulator, तुम्हें तुम्हारे formulation में क्या properties चाहिए. Okay, what do you look for, what do you desire, उसके हिसाब से you take up the excipients. All right. And solubility of the drug in the oil phase. Obviously, if you are making oil and water emulsion, if your drug is hydrophobic drug होना doesn't mean कि वो सब में soluble है. Hydrophobic means it is soluble in oil phase, but it needs a certain condition, right? So based on that, the solubility of your drug in the oil phase also becomes primarily. So actually this should be the first point. This should be the first point, then this, and then this. Fine. So solubility of the drug in the oil phase, se bhi you will select your which oil you will be using. And obviously then the desired consistency of emulsion, वो भी physicochemical properties में आ गया. ये इसमें तुम उसकी rheological properties देखोगे कि कैसे बन रहा है. Is it not too viscous? Is it too less viscous? उसका application क्या है? In case if you're making a cream, okay, First tell me, is cream an emulsion?
Yes.
Yes.
Cream is an emulsion. And even you have oral emulsions. So दोनों में consistency में तो difference आएगा. Which one will be more consistent? Or which one will be having a high?
Oral emulsion will be more consistent.
No, which one will be having higher consistency? Cream will have higher consistency, na? It will be more viscous. So the requirement for a cream based on the physical appearance, physical texture and the consistency, iska requirement will be alag and iska requirement will be alag, right? So based on all those things, you will select your oil phase. Okay. So in creams, you use higher levels of not oils, but you use waxes and all of that, which are higher in molecular weight. They are more solid, right? You need to heat them up to melt them. So in that case, you will use waxes and paraffins and all of that, beeswax, etc. In oral emulsion, you won't use all of that. You will use oils and MCTs and all. Yeah. Also, you must understand that when you use these oils and all, oils will also have some amount of pharmacological action. Thoda action होगा. In case if you're giving it oral, maybe uska thoda laxative effect ho jaye in case you're using a castor oil, say, or some other oil, it will have some nutritional value also, peanut oil and all that. Fine. So the oil phase is rarely inert. Okay, it's rarely inert. It is mostly having some action of its own. So you also must select an oil based on कि वो action complement करे. Okay, if you are looking for some oral emulsion जिसको you want to have more residence time in your GIT. अच्छा, तुम्हें एक ऐसा करना है जहां पे GIT में उसका residence time increased हो. And castor oil, you know, it acts as a laxative. Okay, it stimulates the bowel movement. So will castor oil be helpful in this application?
Yes.
How? See, you want कि तुम्हारा GIT में drug ज्यादा time रहे, and castor oil stimulates laxative action. So will castor oil be useful in this case?
No.
No, right? वो फटाफट movement promote करेगा and residence time will decrease. So in this case, castor oil won't complement your application, right? So that is also one criteria. That also becomes a criteria for selecting oil in that case. समझा सबको? नाम नामदेव, प्रज्ञा, मधुरा, खुशी तो है.
Yes, ma'am.
साक्षी, माधवी,
Yes.
दिव्या.
Yes, ma'am.
Yes, ma'am.
Okay. All right. Ashiti.
Yes, ma'am.
Okay. Fine. ठीक है? So they are rarely inert. That means most of the time they also have a pharmacological action of themselves. So thus the oil must have complementary action. Mention this point, okay? It must have a complementary action to the intended application. ठीक है? And it may also influence the bioavailability by, see, this is what exactly I'm telling. Gastric emptying time, yeah, gastric residence time. So it affects the bioavailability and all of that. It might provide some additional nutritional value also. So there are many criteria. तुम बस मुंह उठा के you all can say like मुझे इसमें मेरा formulation बनाना है. Fine. So these, let us now look at what are the different options of the oils, right? So you have vegetable oils, you have hydrocarbon oils, and you have perfluorochemicals. Fine. So in vegetable oil, जैसे मैंने बोला, you have LCT, MCT. LCT is low chain triglycerides. Sorry, long chain triglycerides. Okay. LCT is long chain triglycerides. MCT is medium chain triglycerides. Fine. So in this you will have oleics, linoleics, palmitics, stearic acids. Okay. Soybean, sunflower and all of that. Fine. MCTs may you have coconut oil and all. Then hydrocarbons. So this is usually for your oral and parenteral uses. Okay, this is usually for oral and parenteral uses. Now hydrocarbon mein you have all of these hard and soft paraffins. So ये मैंने बोला ना, ये creams and all के लिए use है. Turpentines is also used for topical purpose. Then you have benzyl benzoates. ठीक है?
Yes.
Silicone oils. Silicone oils, again, they are used for topical purpose and all of that. Fine. Perfluorochemicals are used for your diagnostic purposes. Okay, emulsions made for diagnostic purposes. You have perfluorochemicals. All right. Now coming to emulsifiers, I think emulsifiers we've discussed for like so many times. Fine. So let us just quickly go through it. So here again, मैंने जो बोला था, mainly when we are dealing with it, they are mainly surface active agents and hydrophilic colloids. Okay, these are the two major ones which are widely used. Surface active agents and hydrophilic colloids to maintain and control the stability of the emulsion and all. So emulsifier ka selection will also depend on what type of emulsion you want to make. Oil in water बनाना है, water in oil बनाना है, या फिर multiple emulsion बनाना है. Which are the two types of multiple emulsions?
Oil in water in oil, water in oil in water.
Water in oil in water. Okay, fine. Then also the toxicity and the irritancy potential, because you know surfactants, some surfactants also act as laxatives, and these surfactants, when you talk about surfactants and when you talk about hydrophilic colloids, like say your polypropylenes or something like that, also they have some amount of toxicity and irritancy to the body. So suppose in one case तुम्हें you are using say कौन सा surfactant flow, polaxamer, suppose you are using polaxamer, and in another case you are using, tell me one emulsifier.
Polysorbate 80.
Okay, PS80. And one more, we'll take acacia also. Okay, natural gum. Okay, so in this case तुम्हें polaxamer for a particular formulation, तुम्हें polaxamer इसमें बस 20 mg चाहिए. Okay, 100 ml में. Okay, 100 ml में मुझे 20 mg चाहिए. जो इफेक्ट मुझे चाहिए, स्टेबिलिटी चाहिए. Okay, the desirable stability that I want, the polaxamer is 20 mg of polaxamer. If I use, it is giving me a desirable stability. In case of PS80, I will require 35 mg. These are just random numbers I'm taking, okay? And for acacia, I need, say, for same effect, I need 40 mg. All right? So which according to you is the best? इसके हिसाब से
Polaxilla.
Polaxam.
Because कम क्वांटिटी में मुझे सेम इफेक्ट मिल रहा है. सो व्हाई शुड आई यूज मोर ऑफ एन एक्सिपिएंट? बट US FDA में I told you na, in US FDA you have something like the IIG, inactive ingredient guidelines, and inactive ingredient database, IIG and IID you have, which tells के ये सारे excipients का maximum daily intake, that is MDI, और maximum daily exposure MDE कितना होना चाहिए for a particular route. Okay, so ये हम oral की ही बात कर रहे हैं. So again, random values. Abhi, if I look at the MDEs, if I look at the maximum daily intake or exposure level, polaxamar for an oral route, only 15 mg is allowed. So 15 chodo, 18 mg is allowed. For polysorbate 80, 20 mg is allowed. And for acacia, 50 mg is allowed. Now you tell me, मैं कौन सा यूज कर सकती हूँ?
Acacia.
You all are getting the point कि इसका सेफ्टी इज प्रूव्ड कि 50 mg ओरली मैंने अकेशिया दिया तो पेशेंट को कुछ प्रॉब्लम नहीं होगा. इट्स सेफ. ओके, इट्स कंसिडर्ड, yeah, it's considered fine. All right. Okay, now formulators can use this also. Polaxamar भी यूज कर सकते हैं 20 mg, but they will have to perform toxicity testing, they will have to perform toxicity profiling, they'll have to do so many other tests to prove that 20 mg is also safe. And once they prove that 20 mg is also safe, this will then be updated to 20 mg. ये नंबर्स कहां से आते हैं एमडीए पे? बिकॉज किसी ने वो कॉन्सेंट्रेशन पे टेस्ट किया रहेगा. तो कल जाके मैं अकेशिया को 100 mg पे भी अगर टेस्ट करके प्रूव करूं कि इट इज स्टेबल, देन दिस विल बी अपडेटेड टू 100 mg. सो मे बी अगर मैंने प्रूव कर दिया, तो अगर तुम्हें बनाना है नेक्स्ट टाइम, सो यू कैन टेक अ रेफरेंस ऑफ दिस कि अरे 100 mg इज ऑलरेडी प्रूव, तो 100 के अंदर आई कैन सेफली प्ले. But if you don't want to do all that toxicity profiling and clinical testing and all of that, then the safe thing which you need to do is stay within the limits. All right. So as per that, acacia. So this also needs to be checked. समझ आ रहा है सबको? I'm teaching you all a little advanced. I hope you all are keeping up.
Yes.
Everyone?
Yes, ma'am.
Very
Yes,
good.
ma'am.
Very good. Then what is the clinical usage of emulsion? Clinical usage मतलब वही, what is the route of administration and what is the indication you are using it for. जैसे मैंने बोला सिंपल क्रीम की ओरल एंड ऑल ऑफ दैट. अच्छा, ये एमडीई में मुझे और एक पॉइंट हाईलाइट करना है. मैंने बोला एमडीई इज डिपेंडेंट ऑन द रूट ऑफ एडमिनिस्ट्रेशन. ठीक है, इट्स डिपेंडेंट ऑन द रूट ऑफ एडमिनिस्ट्रेशन. सो यू टेल मी, ओरल या पैरेंट्रल, किसमें एमडीई ज्यादा हो सकता है, ज्यादा रख सकते हैं हम?
Parenteral.
मैक्सिमम डेली एक्सपोजर. ओके, मैक्सिमम डेली एक्सपोजर हम कौन से रूट ऑफ एडमिनिस्ट्रेशन के लिए ज्यादा हो सकता है?
Oral.
ओरल के लिए ज्यादा हो सकता है, बिकॉज पैरेंट्रल में इट विल ऑलवेज बी लेस. सपोज PS80 का लिमिट इधर कितना बोला था मैंने, 20 mg है. सो इन दिस केस इट विल बी 15 mg or 16 mg only. Why will it be less in case of parenteral?
Bioavailability is 100.
हाँ, because it's going directly into the bloodstream, directly in your systemic circulation. समझा सबको?
Yes, ma'am.
Everyone keeping up? Ashiti,
Yes, ma'am.
Divya, Madhura?
Yes, ma'am.
Yes, ma'am.
Okay.
Yes, ma'am.
And then obviously comes the cost and availability. अगर मुझे मैं ये दोनों यूज कर सकती हूँ, सपोज दोनों फिट बैठ रहा है एंड ऑल, देन कॉस्ट, अवेलेबिलिटी एंड ऑल ऑफ दैट, बट स्टिल आई प्रेफर PSAT बिकॉज अकेशिया नेचुरल सोर्स है, नेचुरल सोर्स में कंटामिनेशन, वेंडर सिलेक्शन, ऑल दैट बिकम्स इम्पोर्टेंट. ठीक है. सो बेस्ड ऑन मेनी थिंग्स आई टोल्ड यू राइट, तुम्हारा प्रोडक्ट है, तुम्हें डेवलप करना है, यू नो व्हाट प्रॉपर्टीज यू वांटेड टू हैव. So based on that and based on the limits and the guidelines provided by the regulatory bodies, you will try and make your formulation in that. And this is the HLB scale जो अभी तो मैं बोलूंगी बचपन से पढ़ रहे हैं, because we are studying it from like surfactants and post dispersions and every time we've been studying it. So this HLB scale सबको पता रहना चाहिए. Fine. So now let us look. We looked into what criteria of emulsifiers should we be looking into. Now these are some example of synthetic emulsifying agents. And as you all know, surfactants are of different types. You have anionic surfactant, you have cationic, non-ionic, polymeric में जैसे polaxamers मैंने बोला, then fatty amphiphils है. So these are these are the different synthetic emulsifying agents used for different purposes. Cationic is usually used for topical. Parenteral mein you have the sorbitans, that is twins. You have polaxamers. Fine. Then these days you also have some other which are not there in your syllabus. You have some more novel type of emulsifiers here. ठीक है. Also look into water in oil में कौन से है. ठीक है. You have spans here. And all of these fatty amphiphils are in water in oil. Again, fatty amphiphils, why? Because it is more hydrophobic. So it will form, the continuous phase will be hydrophobic, that is oil. Then these are some natural emulsifying agents. I gave an example of acacia. Then you have methyl cellulose. They are polysaccharide के class में आता है. Phospholipids, yeah. The emulsions formed using phospholipids is called a lipid emulsion. And these are one of your complex preparations. मैंने हम बोला था ना बीच में complex drug products, complex products. Okay. So ये जो nano emulsions, and they form nano emulsions. Okay. Lipid emulsions. I'm working on this as well. Lipid emulsions. Then sterols, that is wool fat and all, finely divided solids आ गया. ठीक है. So yeah, these are used for parenteral purpose. Phospholipids, उसमें तुम्हारा lecithins आ गया. Then you have EPC, that is egg phosphatidylcholine. Okay, egg phosphatidylcholine and all. So now, okay, so we've understood the major part of the excipients and all. Now let us look into the manufacturing of these emulsions. So तुम लोग ने lab में तो formulate किया ही होगा emulsion. So just tell me, how did you all make a emulsion? How did you all make an emulsion in lab? First tell me, was it a coarse emulsion or a colloidal or a nano emulsion that you all made? लैब में इमल्शन बनाया है. हेलो. हाँ.
No, ma'am.
Which year are you all in? Third year.
Ma'am, for the first year we were in online mode.
अच्छा, तो डेमो में भी नहीं हुआ क्या? किसी ने बनाया भी?
No,
What nonsense. You all didn't have practical component at all.
it was all theoretical part.
In all the colleges.
No, in my
Yes.
college.
No. Come on, not in all the college. इधर एक BCP वाली भी है ना?
Ma'am, I was only telling it was in online mode.
You are from BCP Madura.
Yes, ma'am.
शिंदे मैम ने लेने दिया क्या? Online, no practical.
Ma'am, then we did not have Shinde, ma'am. We had Harita ma'am.
Oh, okay. Okay. Anyways, so no idea how an emulsion is made. You'll miss so much. I'll just explain you all now. तुम लोग को वीडियोस भी नहीं दिखाया था.
दिखाया था मैम, but it was like when we actually do it, we remember it well.
So right now you mean what I'm teaching you, you won't remember.
No ma'am, not.
Then, anyways, you all are supposed to remember. In fact, if you all don't get to do a thing and if somebody is trying to explain you all should take more efforts to remember it, to know it, provided you are interested in it. Anyways,
Yes ma'am.
so if you have, say I want to make a water in oil emulsion, इधर ही जो लिया है वो बनाते हैं, water in oil emulsion. तो बोलो water in oil emulsion में drug कहाँ रहेगा, water में, oil में?
ऑयल में.
कुछ ही थोड़ा सोच के बोलो ना खुशी. अगर ऑयल में ही रहना है तो मैंने वाटर डाला ही क्यों है? टेल मी खुशी, यू ओनली टेल मी.
इन वाटर.
ऑब्वियसली अभी दूसरा ऑप्शन क्या है? करेक्ट.
यस.
वाटर में रहेगा. ओके अगर ऑयल में ही रहना है तो मैं वाटर डालूंगी ही क्यों? और अगर वाटर डालना है तो मैं ऑयल इन वाटर ना बना दूं. ओके सो वाटर इन ऑयल बनाना है, सो माय ड्रग विल बी इन water phase. Okay, so first what I'll take is I'll take water and in this I will solubilize my drug. Okay, and then here I will take my oil phase. Now water in oil emulsion बनाने के लिए emulsifier का HLB वैल्यू क्या होना चाहिए? हाई और लो?
हाई.
हाई होगा तो हाइड्रोफिलिक होगा, लिपोफिलिक होगा? Okay, tell me, emulsifier should be lipophilic or hydrophilic in this case? Madhura.
Hydrophilic.
What is the continuous phase? Water in oil emulsion में continuous phase क्या है?
Oil.
ऑयल.
थोड़ा एप्लीकेटिव बेस पूछ दिया तुम लोग का फ्यूजेस उड़ जाता है. You all just want to listen mechanically all the lecture and then just keep it on in your head. Don't want to think the applicative part of it. ऐसे कैसे होगा तुम लोग का? You all are in a technical course, pharmacy. I'm getting some M.Pharm students जिनको like there's some B.Pharm students who are better than M.Pharm students. Please don't become such students. तुम लोग बाहर किधर भी नाइपर and all जाओगे, just going into नाइपर doesn't prove anything. Make yourself worthy of going over there. थोड़ा तो एप्लीकेटिव सोचो. हम कब से क्या बोल रहे थे? रूल ऑफ बैनक्रॉफ्ट. किसने बोला था रूल ऑफ बैनक्रॉफ्ट मेरे लिए?
Me ma'am.
तुमने ही बोला था ना. देन वाटर इन ऑयल इमल्शन के लिए इमल्सिफायर किसमें सॉल्यूबल होना चाहिए?
In oil phase.
तो इट विल बी हाइड्रोफिलिक और लिपोफिलिक.
लिपोफिलिक.
Lipophilic.
एंड इफ इट इज लिपोफिलिक उसका HLB वैल्यू कम होगा ज्यादा होगा?
ज्यादा होगा.
कम होगा.
थैंक यू. कम होगा. आई टोल्ड यू ऑल HLB वैल्यू इज फ्रॉम 0, 9, 18. हाउ आर यू गोइंग टू रिमेम्बर? HL ऊपर हाइड्रोफिलिक नीचे लिपोफिलिक. तो इधर it will be less. I'm going to now this time your upcoming test, I'm going to make sure that the test is super tough. I'm highly disappointed with you all. थोड़ा applicative questions पूछे हैं. When is your test? When is your test scheduled for emulsions? बोला है?
No, ma'am.
No, ma'am.
Norman, you're there? Norman or Radhika? ठीक है, I'll make sure. You're going to have a tough time in this test. ठीक है. So HL उसका it will be lipophilic. So मैं अपना emulsifier इसमें dissolve करूंगी कि इसमें dissolve करूंगी?
Oil.
Thank you. So here I will dissolve my oil. और इधर लिखा भी था, मैं इसका ही एग्जाम्पल ले रही फिर भी. एनीवेज, सो मैंने ड्रग को सो फॉर वाटर इन ऑयल इमल्शन मैंने ड्रग को वाटर में सोल्यूबलाइज कर दिया, इमल्सिफायर को ऑयल में सोल्यूबलाइज कर दिया. एंड सिंस आई एम मेकिंग वाटर इन ऑयल इमल्शन, ऑयल बिकम्स माय कंटिन्यूअस फेज. मैं वाटर को ड्रॉप वाइज इसमें ऐड करूंगी एंड आई विल mix it or I will subject it to high pressure homogenizer, or another one is high shear homogenizer. Okay, or in simple thing I can also triturate it or mix it in mortar and pestle. So इधर तो obviously coarse range का ही बनेगा. In this case it will be a nano size of emulsion. ठीक है. So ये सब techniques से there will be breakdown of these water and it will, the emulsifiers and all will come at the interface and all, and it will at the end form a water in oil emulsion. So these are water globules suspended in the oil phase. और ये जो black color का चीज दिख रहा है आजू बाजू, that is nothing but your emulsifier. And your drug is dissolved here. Okay, your drug is dissolved in water. So this is how you will form an emulsion. ठीक है? Understood anyone? Any doubts?
No, ma'am.
Okay. Industrial scale में भी same होता है, but at higher level, wherein suppose again in this case also, in this case you are making oil in water. Okay, in this case you are making oil in water. So tell me drug कहाँ जाएगा?
Oil, please.
Thank you. But there was a question mark in your voice, huh? Oil phase में जाएगा. Say confidently. And इसमें कौन सा emulsifier use होगा?
हाइड्रोफिलिक.
Hydrophilic emulsifier. तो उसका HLB will be
मोर.
Hi.
Both.
ठीक है? Fine. So and that will be in my water phase. So इधर मेरा emulsifier आ जाएगा. And then इसको मैं, as it's coming here, इधर pump से, it will be pumped here and there will be continuous stirring. This is the stirrer. Okay, there will be continuous stirring, and then this will eventually be pumped into the high pressure. It's going like this, high pressure homogenizer, and वो वापस cycles चलाते रहता है. So it will go here, it will go here. Once all the oil phase is transferred, ये हो गया. अभी ये water phase homogenizer से pass होता रहता, and then there's उतना finer तुम्हारा globules बनता जाएगा. And at the end, it is packed in your bottles or vials or whatever. You can further spray dry it to get a solid this thing also. तो solid तुम्हें oil के globules बन जाएंगे. However, इस पे it's not that relevant right now. But then it is packed. So this is what happens in your emulsion scale, wherein these vessels, they are jacketed vessels because you might need to maintain certain temperature. Okay, then you have these propeller mixers and all of that. Okay. And one more thing, in industry, when you're making these things, all of these jacketed vessels and all are made of SS316L. ओके वो ग्रेड का स्टेनलेस स्टील से यूज होता है, दैट्स अ फार्मास्यूटिकल ग्रेड। ठीक है, सो दीज वर द टू वेज, लैब स्केल बनाना एंड इंडस्ट्रियल स्केल बनाना, एंड दीज आर सम इंस्ट्रूमेंट्स व्हिच आर यूज्ड while making the emulsion. Fine, these are the instruments which are used, or the agitation techniques. You have high pressure homogenizer, you have high shear homogenizer. High pressure homogenizer को microfluidizers भी बोलते हैं. You have membrane homogenizer, colloid mills हमने बहुत बार पढ़ा है. Ultrasonic device. Simple mixing is just to mix in the mixing tanks. Mixing tanks में mix करने के लिए, but जहाँ for the formation of emulsions, okay, you need these things, either like 1, 2, 3, 4, 5, okay, these things, or high shear homogenizer also. So now which technique will you select? Okay, उसमें भी अलग अलग क्राइटेरिया होता है, कौन से टेक्निक सिलेक्ट करके तुम बनाओगे. So how much volume of emulsion is to be prepared? If it's a huge volume, then तुम high pressure वाला use कर सकते हो. Small volume के लिए high pressure homogenizer use नहीं कर सकते हो. उसके लिए you will need a high shear homogenizer or a ultrasonic device. What type of emulsifier are you using? What type of emulsion are you making? तुम्हें तुम्हारा जो droplet या globule size है, कितने size का चाहिए? बहुत कम size का चाहिए, you need more effective instrument. थोड़ा ज्यादा size चलेगा, then accordingly. What should be the flow of your emulsion? That's your rheological properties. Okay. Emulsification and cooling process क्या है? All of that. So based on these requirements and these criteria, you will select the machine. Now this was a simple way of forming an emulsion. Now there's another way, indirect way of preparing an emulsion, which is called as a phase inversion method. Okay. So in this case, what you do is, okay, your end product is, say you want to make an oil and water emulsion. Okay. So first what you will do, you will heat it. Okay. You will heat the oil and water. इसमें तुमने तुम्हारा drug जिसमें dissolve करना था वो सब कर दिया. Okay. You heat it. Okay. And that heating process will form, say, one water in oil emulsion. And then at a phase inversion temperature, PIT, phase inversion temperature तक तुमने heat किया. Okay. So it will form a water in oil emulsion. And then once you cool it, what will happen? The solubility of the emulsifier will change. Okay. In this case, your emulsifier was soluble in oil phase. Okay. But then because of the change in temperature, the emulsifier ka solubility will change. It will solubilize in water. And thus, if the emulsifier is water soluble, it will form an oil in water emulsion. Simple. So this method is dependent on the PIT, that is phase inversion temperature, and second, the solubility nature of your emulsifier. Okay? This is a thing. So you first heat it to form a water in oil emulsion, and then you eventually cool it to get an oil in water type of emulsion. This is usually done in the formation of creams and some topical formulations. Okay. Topical formulations usually done to obtain an oil in water emulsion. Now, agar isko वापस heat kiya, then वापस it will form this. So because of this phase inversion nature, this can become a problem also in case of transporting and all. Suppose your product is stable at 25, but तुम्हारा emulsifier का emulsion का phase inversion temperature is say 40, 50. And during transport and environmental conditions, it is exposed at that. So it can phase invert in that case also. Okay, so this is one good thing in make formation and all, but it can lead to a problem as well. Okay, understood phase inversion method?
Yes.
Any doubt?
Yes, ma'am.
All right. So now we've studied which are the different types of
Ma'am, like
huh.
inversion,
What?
phase inversion, what type of like problem it causing? In phase inversion, what type of problem is it causing? Like,
इन्वर्ट हो जाएगा तुमने ऑयल इन वाटर बना दिया बिकॉज ऑफ द फेज इन्वर्जन टेम्परेचर एंड ऑल ऑफ दैट अगर ट्रांसपोर्टेशन एंड ऑयल के टाइम हायर टेम्परेचर पे डाल दिया तो ऑयल इन वाटर का वाटर इन ऑयल हो जाएगा समझा
like मैम प्रॉब्लम क्या होगा रिलेटेड टू दैट?
प्रॉब्लम ये होगा कि ये पूरा चेंज हो गया ना तुम्हारा फाइनल प्रोडक्ट यू वांट ऑयल इन वाटर बट बिकॉज ये चेंज हो गया तुम्हें वाटर इन ऑयल मिल गया इजंट दैट अ प्रॉब्लम
यस
तुम्हारा ड्रग स्टेबिलिटी एंड ऑल दैट पे भी इफेक्ट हो जाएगा
यस
गॉट इट So now we've studied different types of emulsions, oil in water, water in oil, and this and that. But which are the ways of identifying? तुम्हें अगर bottle में दो emulsion दे दिया, how will you identify if it's oil in water or water in oil? Or even while when you're dealing with such say methods and all of that, how will you understand that the method which I'm using is actually properly forming what I want? So you have some identification or some QC tests which will help you in understanding if your emulsion, the emulsion you want to make, has actually formed or not. And again, emulsions, जैसे हमने discuss किया, they are spontaneous and they are very highly thermodynamically unstable. So for that also, stability is a major concern. So you have to test the physical and the chemical stability of the emulsion also. Emulsion का cracking होता है, सुना है?
Yes.
What is it, Sakshi? Cracking of the emulsion? Mute कर दिया. Sakshi. What is cracking of the emulsion?
Oil and water
form
phase.
Yeah, Pragnya, tell.
Phases are separated.
Rishika, come again.
The two
for
phases get
example
separated.
milk.
Khushi, wait. Khushi, wait. Yeah, Rishika, go on.
The two phases get separated. Is cracking.
Is cracking, right? Tumhara, say oil in water mein all the oil coalesce together and it will form two separate layers. You can actually see two separate things. That is cracking of emulsion and it's one of the major concerns, right? So let us look into all these stability issues and all. So first, let us understand the QC tests. Okay. So in QC tests from say number 1 to 7, you have the different tests of identification of emulsion कि कौन सा oil in water है कौन सा water in oil है and all of that. Then is the droplet size distribution, particle size and all, zeta potential, particle size, zeta potential, which is the machine which is widely used for determination of this? Particle size and zeta potential. DLS बोला था ना मैंने कितनी बार? Dynamic light scattering machine. कोलॉइड्स में हमने डिस्कस किया था.
Yes.
Then rheological properties. Okay, using a which is the machine जिससे तुम rheological properties determine कर सकते हो? अरे rheological properties
Viscometer.
viscometer, rheological properties. Rheometer. Am I teaching this to the students in some other parallel universe? Because I don't think these students remember anything. दिवाली की मिठाई सबको सर पे चढ़ गई क्या? प्रज्ञा, खुशी, मधुरा,
Yes, ma'am.
क्या? हाँ, सर पे चढ़ गई दिवाली की मिठाई।
No, ma'am.
No, ma'am.
रश, ऋषिका, दिव्या, तुम लोग बस सुबह उठ के ऐसे ही आ गए ना? चालू कर दिया ना? आई थिंक आधे लोग तो बेड पे ही होंगे। DLS you all forgot, rheometer you all forgot. Haven't we discussed this?
Yes, ma'am.
प्रज्ञा, GPAT कब है तुम लोग का?
25 में।
और नेक्स्ट ईयर तो बस 24 ही है, मतलब नेक्स्ट टू नेक्स्ट ईयर है। याद रहेगा तब तक? Anyways, let us begin with the QC tests. The first test is called as water oil miscibility test or dilution test or spreading test. Okay. So इसमें basically in these tests, what you have to remember, what is the principle of the test and what is the result, observation and inference of the test. ठीक है? So in this, the principle is an emulsion will only mix or spread freely with a liquid that is miscible with its continuous phase, obviously. So if you have an oil in water emulsion, if you dilute it with water, will there be any two separate phases? ऑयल इन वाटर इमल्शन लिया, उसको तुमने और वाटर डाला उसमें, so will there be any two different phases? It will remain same only.
Will remain same.
Two different
Why?
things.
Because उसका कंटिन्यूस फेज पूरा वाटर है, तो तुमने वाटर में और वाटर डाल दिया तो उससे कुछ फर्क नहीं पड़ेगा, इट विल रिमेन फेज, नो चेंज. बट अगर इसमें तुमने ऊपर से ऑयल डाला, इसमें तुमने ऊपर से ऑयल डाला, then it will form a separate layer, right? Because it is not miscible. So by this you will get to know that my emulsion is oil in water. उल्टा केस लेते हैं, water in oil emulsion में मैंने oil डाला, will there be any change?
No. No.
Because it is miscible with the continuous phase. ऑयल में ही मैंने और एक्स्ट्रा ऑयल डाला तो उसमें कुछ फर्क नहीं पड़े, बट अगर मैंने इसमें वाटर डाला तो फिर it will form a separate layer. ठीक है? So this is how you will identify. Please stop me if you all have any doubts. Okay. Then the second test is called as the filter paper test, and इसी से you can also understand the viscosity also in a very qualitative manner. क्वांटिटेटिव स्टडी करना है विस्कोसिटी का तो तुम्हें रियोमीटर से ही पता चलेगा. ठीक. सो फिल्टर पेपर टेस्ट में क्या होता है? वाटर, इफ वाटर इज द एक्सटर्नल फेज, then it tends to spread more rapidly throughout the filter paper than oil. And water in oil emulsion is more viscous than the oil in water emulsion. Because oil in water emulsion mein water is the continuous phase, it is less viscous, so it will spread more rapidly. So what I'll do is मैंने दो फिल्टर पेपर लिया है सर्कुलर, और दोनों के बीच में मैं emulsions रख रही हूँ, तो सेपरेट emulsions रख. ठीक है? You see, in case A there is फटाफट spreading, but in case B there is slower spreading, correct? इधर मैंने रखा और ये immediate spread हो गया, but इसको टाइम लगा, एंड ऑल्सो ये बहुत कम स्प्रेड हुआ, ये कितना ज्यादा स्प्रेड हुआ है, राइट? सो विच वन, व्हाट कैन आई कंक्लूड, वेयर इज माय कंटिन्यूअस फेज? कहां पे कौन सा क्या कंटिन्यूअस फेज है?
A has a water continuous phase and B
So what
has
is
an
this
oil
emulsion?
continuous.
If this is
Oil
water,
in water.
this becomes oil in water, and this becomes
Water in oil.
water in. Understood, everyone? Clear, everyone?
Yes, ma'am.
Yes,
Okay.
ma'am.
Then another one is again interesting. The fourth one is a conductivity test. So what is the principle here? Water conducts electricity better than oil. Better क्या है? Conducts electricity. So इधर मैंने अपना emulsion रखा and इधर मैंने electrode से bulb connect किया. Now because currently this emulsion is water in oil emulsion, the bulb is not glowing. Why? Because the continuous phase is oil. Water भी है थोड़ा थोड़ा, but the bulb doesn't glow. It's not enough to conduct electricity. But now when I'm putting, if I'm replacing the sample with oil in water emulsion, so here water is my continuous phase, correct? Water is a good conductor of electricity. So जैसे मैंने इसका switch चालू किया, the bulb starts to glow. Okay? So in that case, I can conclude जहाँ पे bulb अगर glow हो रहा है, so this is my oil in water emulsion because my continuous phase is water. Fine. Now the fifth test, now fifth, sixth, and I think even the seventh, they all are dye-based tests, color-based tests. अभी तक हमने सारी physical properties के हिसाब से पढ़ा. Now these are dye solubility tests. Okay. So the principle here is blending of either a water soluble dye or oil soluble dye with the corresponding emulsion. Now suppose I'm using amaranth as a dye and amaranth is water soluble. ठीक है? Amaranth red color का होता है, it is water soluble. So in this case, because my continuous phase is water, amaranth पूरे ये continuous phase में spread हो गया है, and that is why, okay, the emulsion will appear red in color. Okay, because my dye is soluble in water, pura continuous phase is water, so the emulsion will appear red. Okay, but in case of water in oil emulsion, water is just present in form of globules, correct, in form of droplets, and my dye is not soluble in oil, so it will just spread over these droplets. So my emulsion will appear transparent with red droplets in it. Now, what will be the case if I'm having, so okay, amaranth is water soluble. Now, suppose I'm using Sudan 3. Sudan 3 is a green dye. Sudan 3 is a green dye. Now, tell me what will be the case if I am using Sudan green? इसमें क्या होगा? Oil in water emulsion में क्या case होगा? How will the emulsion appear?
Green.
It will appear green.
Yes, the continuous phase is green.
Divya, tell me.
Droplets will appear green and water phase will be clear.
Very good. Droplets will appear green. ये oil soluble dye है. Oil soluble dye water में soluble नहीं होगा ना. Only oil में soluble होगा. So only this will appear green. So the overall emulsion will appear transparent with oil green droplets. And what about water in oil emulsion? In this case, how will the emulsion appear?
The continuous phase is green.
Correct. Now the continuous phase will be green with transparent oil droplets in it. समझा सबको?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Next is fluorescence test. Fluorescence test में क्या principle है? That the oil phase illuminates after UV exposure. अगर oil phase है तुम्हारा और तुमने उसको UV में expose किया, it will glow up. So water in oil emulsion जिसमें there is lot of oil in the continuous phase, there will be a continuous fluorescence. पूरा emulsion will glow. But in case of, this is only in exposure to UV light. But in case of oil in water where you have oil droplets, there will be a spotty fluorescence. Specks of light will appear. That's simple in fluorescence test. Cobalt chloride test में क्या होता है? ध्यान से सुनो. Cobalt chloride solution will turn oil in water emulsion to pink color. तो इसमें क्या करोगे तुम? You will take, these are some extra tests. Cobalt chloride is not in your syllabus. And even fluorescence is not. So these are extra tests. तुम filter paper लोगे. Filter paper को cobalt 2 फिल्टर पेपर लिया, उसको कोबाल्ट क्लोराइड सोल्यूशन में डिप किया एंड ड्राई किया. सो आई हैव 2 कोबाल्ट क्लोराइड कोटेड फिल्टर पेपर. अभी एक में मैंने एक को मैंने डिप किया, सो it's like now like a litmus paper only. Okay, but okay, forget, it's not like litmus paper, but I took 2 filter papers and both of them are dipped and dried in cobalt chloride. एक को मैंने ऑयल इन वाटर में डिप किया. ओके, एक को मैंने ऑयल इन वाटर में डिप किया एंड दूसरे को मैंने वाटर इन ऑयल में डिप किया. नाउ टेल मी विच वन विल रिमेन सेम एंड विच वन विल टर्न पिंक.
Water in oil will remain same and oil in water will turn pink.
Pink, because that is what it's saying. Okay, cobalt chloride will turn pink if the continuous phase is water. Okay, so that is the thing. Now coming to stability, so I hope you all understood the identification tests and principles, right?
Yes, ma'am.
Yes.
Yes.
Now stability are of 2 types, chemical and physical. तो chemical stability में तुम्हारा drug क्या होना चाहिए? Your drug should be stable, degrade नहीं होना चाहिए and all of that. So उसके लिए you will do titrations, HPLC analysis and all of that. You will incorporate antioxidant preservatives, properly select oils and all. The important thing here, so chemical stability is very important, but something which is specific is physical instability. So let us look into it. This is how my normal emulsion is looking. This is, say, oil in water emulsion. One kind of physical instability can be phase inversion. Phase inversion में क्या होगा? Oil in water emulsion will become
Water in oil.
at what temperature?
High.
High temperature.
Inversion temperature.
Phase inversion temperature. Okay, and that depends on the dash of dash. Solubility of,
Emulsifier.
thank you, solubility of emulsifier. Then you will have flocculation. Tell.
But if the emulsion is oil and water, then the water amount will be more. So how will the inversion take place?
So because of the change in temperature, I told you, because of the change in temperature, there'll be a change in solubility of the emulsifier. This is totally depend on the solubility of the emulsifier if it has a temperature dependent solubility. Okay. This will have a temperature dependent solubility. So in that case, वो जो temperature पे जिसमें soluble होगा, वो type का continuous phase हो जाएगा.
Okay, ma'am.
Understood?
Yes, yes.
Okay. Then another thing is flocculation. I told you all while explaining suspension also, okay, flocculation इसमें भी होता है emulsion में. So it is the similar thing, same thing. Then you either have sedimentation or creaming. Okay, sedimentation or creaming. Sedimentation, say if your oil, okay, sedimentation happens in water in oil. Okay, it happens in water in oil emulsion where what oil is less dense, correct? So water globules will settle down because water is more dense than oil, correct? Water is more dense than oil. तुम लोग घर पे वाटर लो, उसमें तेल डालो, तेल ऊपर रहेगा कि नीचे आएगा? ऊपर रहेगा. Why will it float up? Because it is lighter, it is less dense than water. Got it?
Yes, ma'am.
So in case if you're having water in oil emulsion, water is more dense. तो उसका globules है ना, वो eventually नीचे settle होने लगेगा. So that will cause sedimentation. In oil in water, because your oil globules are less dense, they will go upwards. So this is called, the upward wala is called creaming and the downward settling is called sedimentation. Sedimentation water in oil में होता है, ये oil in water में होता है, and this is dependent on their density. ठीक है? Then another is Oswald ripening. Oswald ripening याद है सबको? कौन से टॉपिक में पढ़ा है ऑसवाल्ड राइपनिंग?
Suspension.
थैंक यू। याद है सबको उसमें क्या होता है, किस वजह से होता है? डैश एंड डैश साइकिल
Suspending agent.
Freeze and thaw.
Due to fluctuation in temperature.
ड्यू टू फ्लक्चुएशन एंड टेम्परेचर। एंड ये फिल इन द ब्लैंक्स किसी ने बोला था अभी?
Freeze and thaw cycle.
वेरी गुड, फ्रीज एंड थॉ। Not everything in suspension is related to the suspending agent. So don't give those dumb answers, please. Okay? And ये हुआ तो in case of flocculation, it is reversible. In case of sedimentation and creaming also, it is reversible. इसका भी तुमने temperature proper किया तो even this can be reversible. But if this extends a lot, then all these smaller will become a big globule. It will become big. Either be they can coalesce, and coalescence agar ho gaya, then there's no going back. There is no going back. It will completely phase separate, and this is called as cracking of emulsion. Understood, everyone?
Yes, ma'am.
Okay. So yes, as I said, creaming is the upward movement of the oil droplets. Okay. And this happens in oil in water because oil is less dense. And sedimentation is the downward movement. And this is in water in oil. Okay. And both of them are a reversible process. Reversible, मतलब उसको disperse किया ना, shake well before use. Emulsion, suspension, दोनों में shake well before use करना होता है. So if you shake it well and properly, they can easily be redispersed again by agitation. ठीक है? And it occurs inevitably in any dilute emulsion containing large droplets. So ये सब problem ना because of droplet size होता है, usually large droplet. That's why nano emulsions are more stable. Okay, they are more stable because कम size है, it's easy to disperse, redisperse. Then flocculation also I've told you. This is also reversible. It can be redispersed. ठीक है? It's because of some weak association between them. ठीक है? And इसमें भी the flocks will behave as a single unit. ठीक है? Coalescence is an irreversible process in which the dispersed droplets merge to form a larger droplet. ठीक है? So इसमें क्या होता है, when the interfacial, the repulsive energy इनके droplets में भी I told you ना, that is why zeta potential becomes very important. Zeta potential तुम्हें stability देगा, right? I told you zeta potential beyond what and what is stable?
30 millivolts.
Very good. Beyond minus 30 and beyond plus 30 is stable. But suppose इसके बीच में होगा ना तो ये सारा problem होगा. And because it overcomes the repulsive energy barrier, the interfacial film will rupture and they will coalesce to form larger, and it will eventually lead to phase separation. Oswald ripening bhi maine bola tha, it's because of freeze and thaw temperature thing. And even this is an irreversible process. And it occurs in emulsion which contains sub-micrometer droplet size. मतलब 600 nanometer पे भी Oswald ripening हो सकता है. Okay? So for this, it should be temperature stability होना चाहिए. And ये inversion भी बोला, a change in emulsifier का solubility from water to oil. पहले water में था, then oil में हो गया because of change in temperature, which is the phase inversion temperature. So that is why there is a phase inversion of this thing. So emulsion inversion may also occur, this is an important point, may also occur by specific interaction with other additives. If you add some additives which will eventually change the solubility of the emulsifier, तो उसके वजह से भी होता है. And these are some ways of remedies to mitigate these issues. Creaming and sedimentation के लिए मैंने बोला small droplet size बनाओ, viscosity modifiers add करो ताकि it remains suspended for a longer time. ठीक है? And flocculation के लिए again you use suitable emulsifiers. Here also you use proper polymeric surfactants and all of that. So are you all able to link? Are you all able to link up suspension, emulsion, coarse dispersions, colloids and everything? तुम लोग को याद नहीं है वो अलग बात है, but still I hope you are able to link up things. Yeah?
Yes, ma'am.
Okay. Fine then. So with this, we complete emulsions as the topic. So we are done with coarse, dispersion, emulsions, suspensions. Any doubts in any of these topics? Huh? Any doubts? Are there doubts
No,
here?
ma'am.
So let us quickly solve MCQs. I will share the screen. You all have MCQ booklets with you all, right? Booklets है?
No, ma'am.
ठीक है, तो I will share the screen. So हमने ये बाकी सब भी कर दिया है ना MCQs. Right. Okay, I think we'll do it next time because there are answers marked here only for some reason. What I'll do is I'll get it next time. So we'll maybe do the MCQs next class. Okay, I won't be able to share this. Is it all right?
Yes.
Yes, ma'am.
Yes, ma'am.
Fine. So guys, please study properly and seriously. Itna mehnat se you all are attending class, don't let it go waste. And at least before the lecture, just revise things. At least just before the lecture. Not only for my lecture, any lecture. तुम लोग suppose इसके बाद वाला भी जो lecture है, take some time out, just go through the previous class का notes एक बार, just flip the pages. ये तुम लोग को 25 तक ये सारे concepts याद रखने हैं. Fine? And application का थोड़ा दिमाग use करो. Everything is not going to be fed, spoon fed to you all. Fine? All right?
Yes, ma'am.
Okay.
Yes.
So next class, we'll wind up with these MCQs. And we'll start parenterals mostly. Fine. Parenterals is a very important topic. It's a big topic. It will take time. So, and उसमें तुम्हारा सारा concepts आएगा. Fine. So, pay very attention to that. ठीक है? Or else maybe we'll do liquid dosage forms. वो भी कर सकते हैं. ठीक है? Fine. Then let's wind up for the day. Bye.
Thank you, ma'am.
Thank you.
Thank you, ma'am.
Thank you, ma'am.
Thank you, ma'am.